These are all the edges. It's a vector. So I have to tell if that specific edge, let's say this is the edge of I. This is the edge of I. If that specific edge is part of at least one shortest path. Aryan, what do you mean by one shortest path? You told Aryan, right, that you will have only one shortest path. Correct. I told I had one shortest path value, but that one shortest path value can be achieved by multiple such shortest path. For example, I will take a random arbitrary example, node 0 to node n-1. I have to only consider these two nodes for finding the shortest path between them. Cool. So you can simply see, let's imagine the shortest distance between, again I'm saying shortest distance between this node 0 to node n-1 is, let's say, 5. But this distance 5 can be achieved by multiple such paths. So as you can see, all the pink ones are actually giving me the shortest distance of 5. Right? And again, there can be many other paths from 0 to n-1. As you can see, white ones. There can be many other paths, but they might not be giving you the shortest distance what you wanted, which is 5. So you realize what the problem wants you to know. It says that shortest distance will be there, and the shortest distance can be achieved by multiple such paths that I am calling as shortest paths. Cool. Now, very basic stuff. You have to deal with one edge. As you can see, you have to tell if that specific edge is good or not, which means if that specific edge, again, in this, as you can see, this is the shortest path. So for sure, it is built up of multiple edges. Now, my task is to find out if this specific edge, now, I don't know if this edge is on a dotted line, which means it is a part of a shortest path, or it is not a part of a shortest path. That's a question for me. So now my question revolves or is boiled down to, I have from node U to node V, I have a edge weighted as W. I have to tell if this edge will lie inside one of the shortest path or not. Then arbitrary thinking, what you might end up thinking is that, okay, Aryan, you are saying that this edge, you are confused, this edge should lie inside the shortest path or not. Before even thinking that, I will ask you, bro, your main task is or was to go from node U to node V. Now you had two options. Either you can go directly with the edge which was given to you, or you can take any other list of edges, as in like any other edges, and maybe that can make you reach to node U to node V. But Aryan, direct edge will always be less. No, not necessary. Why? Let's say if this weight would have been 10, but if this edges, all of them would have a weight of 1. So you can simply see, if I would not have taken the edge between node U to node V, and I would have taken the edge which is elsewise, then I would have achieved my answer. So with this, again, that might or might not be useful. We are just discussing a strategy. So this thing, we saw that, Aryan, this seems like this can help us. So what you might end up thinking is that node U to node V distance, I will check the shortest distance between node U to node V, if that distance is actually equal to the edge between them. If that is the case, which means, okay, the shortest distance between node U to node V is good for me, and I can take this edge. Okay, but again, even if I consider that this approach might be true, but you will have to find the shortest distance between every node U and V, which means every node pair U and V. That can be very hectic by simply using a Dijkstras. And in these cases, whenever you have to find the shortest distance between multiple nodes, which means all pair of nodes, you usually end up using a Floyd Warshall. Okay. But that also has a complexity of O of n cube. And by the constraints which are given to us, for sure, this will never work. Now, so we actually realize that we cannot find the distance between all pair of nodes. So that will not work. And again, that was also not the problem was saying, right? You understood? Like we were discussing the shortest distance between node U and node V, but the primarily thing which the problem was saying is you have to consider the shortest path from node 0 to node n minus 1. Again, that can be linked, you might think of, but let's see. Let's take this fact into consideration and this approach also in consideration, and let's mix and see that how I can simply, again, I got to know that the Freud washer is something I can never use. Dijkstras, again, the Dijkstras, which is called as single source shortest path algorithm. Maybe I can use Dijkstras because I know the complexity of Dijkstras is V plus E log V. Sorry, log E. Now, usually people who have just who have done ratification of this Dijkstras, they imagine that the complexity of Dijkstras is V plus E log V. But if you had watched this video in which we have already proved that the complexity of Dijkstras is O of V plus E log E, and why people write O of V plus E log V, they write it because the maximum number of edges can be V into V plus 1 by 2, which is roughly V square. So I can just take a 2 outside, thus I can just remove the constant, thus it becomes a O of V plus E log V. Now, coming on back, we realize that maybe we can use Dijkstras, but Dijkstras is simply says that it is a single source shortest path algorithm, which means from a single source, I can find the distance to all the other nodes. That is what I can achieve, or I can get to you. But I also want the same thing, right? I also want from a single source 0, I just want to find the distance to n minus 1. But Aryan, what about this node U, node V, all this stuff? Correct. Although Dijkstras give me the single source shortest path to n minus 1, but while I am finding the answer for Dijkstras, it will also give me the distance to all the other nodes also from 0. So it is single source shortest path to all the other nodes in the entire graph, which means 1, 2, 3, 5, 4, and so on and so forth. So this Dijkstras, if I apply Dijkstras starting from node 0, it will give me shortest distance to 1, 2, 3, 5, 4, and n minus 1. Although I am right now concerned about 0 to n minus 1 distance only, because that is the prime distance or shortest distance for me, which I have to always make sure I achieve that. But maybe I can use, because you know U and V will one of the middle nodes, so maybe I can use this strategy. Make sure right now we're just thinking of what we can do. That is the reason how our videos are a bit lengthy, because we think of, although I would have never discussed this approach, I would have never discussed this, but still I wanted you to think that how we are going on to an answer. Now, if you're liking it, you can smash the like button. Now, so we realize that maybe we can apply Dijkstras, but for that, again, I combined both the approaches I saw. I used something from both the approaches. I realized I have to use Dijkstras. I will use Dijkstras, okay, 0 to n minus 1. Distance I know, that is, let's say, called as shortest distance. Right now, I was at node U to node V. I want to check if this edge between node U to node V, which is of weight W, shall I keep it or shall I not? Which means, will this give me the shortest distance or not? Or maybe there can be any other shortest path from U to V or V to U anyways, which can give me the shortest distance. How to check that? Simply, if this S would have been less and if this W would have been more, if this S would have been less, if this W would have been more, then what would have happened? Considering that 0 to U, the shortest distance, again, 0 to U, the shortest distance I have assumed to be X, which is the shortest distance. V to U, I have assumed the shortest distance to be Y. Now my task is, shall I take the edge which is above or shall I take the edge which is below, so as to reach from node 0 to node n minus 1? For sure, the one which is having a lesser weight, I will take that. So as to reach from 0 to n minus 1, I will be taking a path of 0 to U having a weight X, okay, X weight done. Then u to v, I know I have two options. I know the bottom one is less, so I will take the bottom one. Okay, I will take a distance of s, and then for sure v to n minus 1, a distance of y. Right, so this gave me the distance, the shortest distance from node 0 to node n minus 1. And if you had remembered, in the very beginning itself, I had computed the shortest distance from node 0 to node n minus 1. So I know the shortest distance. What is the shortest distance? I know this is the shortest distance. So if my shortest distance is actually equal to x plus s plus y, then I know my node w never came into picture, which means my node w, or basically node edge with the weight w, was never used. If that is the case, I will not include that in my answer. But if not, what if this w would have been less and the other edge may be there or maybe not there, but if it would have been more, so your shortest distance would have been x plus w plus y. Then your shortest distance would actually be equal to your shortest distance which you have achieved, which is from 0 to n minus 1, because this is left side also the distance from 0 to n minus 1, because it is 0 to u, u to v, v to n minus 1. This is fixed, this is fixed. This for u to v, you had two options: either take the direct edge or maybe some other edge which gives you shortest distance. But you realized that w itself was giving you the shortest distance from u to v, thus you have taken that. So you realized if this x plus y plus w, if it matches your shortest distance, which is constant for you because you have achieved that shortest distance, let's name it as sd, you have achieved that, it is fixed for you, it is fixed for all the cases, so it is fixed. So you have said that this sd is fixed, this x and this y is also fixed, this w you have taken. If this left side is equal to my right side, which means I have taken the edge w. If this is not equal, which means for sure this left side will be for sure more, in that case I can simply assume that instead of w I would have taken some other value which would have been lesser than w, and that would have resulted me in the shortest distance. Cool. Now everything seems fine so far, and you have achieved that. How will you even check if this w weight was taken or not? By simply checking that, okay, x I have assumed constant, y I have assumed constant, for w I have just added, and if that is equal to my shortest distance, which means w was actually in real life was shortest. If this is not equal, then it is for sure that the left side would always be large, and in place of w I would have taken some other distance which would have been lesser distance between node u and node v. Now Aryan, what is this constant value? Simply, you can see the constant value says x. X is the shortest distance from node u to node 0. But Aryan, you said na that you cannot apply Dijkstras from all the nodes, which means Aryan, you are saying that I will go and find the shortest distance from node u to node 0. I am going to do that. I'll say no. You will find the shortest distance from node 0 to node v, which is actually the same as saying I will find the shortest distance from node u to node 0. And why I am going vice versa? Why I am not finding the shortest distance from u to 0? Why I am not doing that? I am instead doing 0 to u. I am doing this because I know I have previously computed the shortest distance by applying Dijkstras. I have previously computed the shortest distance from node 0 to every other node. So this 0 to node u, I know it for sure. I have computed that already. And the same way I can do it from n minus 1 also. That from n minus 1, I will do the shortest distance to all the other nodes, which means I will apply Dijkstras from node n minus 1. I will apply Dijkstras from node 0, right? And by this fact of applying Dijkstras, I will be having the shortest distance to, because if I apply Dijkstras from node n minus 1, I will have the shortest distance to all the nodes from n minus 1. If I apply Dijkstras from node 0, I will have shortest distance from node 0 to all the nodes, right? From node 0. I will have this by simply applying Dijkstras on two nodes only. Only on two nodes. and then I can go on and iterate on all the edges. I can go on and iterate on all the edges and get the answer. Cool. Let's have a simple trial and let's see what we are doing. Again, if you have liked it, can please smash like baby, because again, I'm just requesting it because like we had zero reach. I don't know why. If it is likeful, you can just comment down below something like that. Let's finish it. So we realize, okay, we can simply apply Dijkstras because our aim is maqsad nahi bola. Our main aim was to find the shortest distance between node 0 and n-1, which is node 5. Sorry, which is distance 5. As I told you that this is a distance, but this can be achieved by many paths. As you can see, 0, 1, 5. It is also giving the shortest distance of 5. 0, 2, 3, 1, 5. Again 5. 0, 2, 3, 5. Again 5. These are 3 paths giving the same shortest distance. Thus, for me, the good edges are this edge, this edge, this edge, this edge, this edge. Again, this is already done, and this is done, and this edge. So these are all the good edges. Remaining one are the bad edges for me. Now, how I will find it? Simply, I will go on to all the edges. Let's say right now I am at the specific edge, which means, okay, from node 1 to node 3, there's an edge. I want to know if this is a good edge or not. So I will take this edge 1, 2, 3, like 1, 2, 3, right? And then again, simple fact, node 0, node n-1. I will check node 0 to node u, node n-1 to node v. The distance node 0 to node u, distance is 4. Node n-1 to node v, distance is 3. Again, I'm saying the shortest distance, which I have computed by simply doing Dijkstras on 0 and Dijkstras on n-1. So with this fact, x is 4, w is 2, y is 3. I achieved the distance as 9. I knew my shortest distance is 5, but this distance is 9. So Aryan, you are saying the distance is 9 is more than 5. So for sure, I would have taken some other path to reach to my shortest distance. So Aryan, are you saying that this w will not be in the answer, which means this edge is not a good edge? Are you saying that, Aryan? I'll say no. Why no, Aryan? Because here in this case, he considered that, okay, this is an edge, u to v. You consider that, okay, this node 0 is connects to node u, this node 0 connects to node v. But I can say that this node 0 connects to node v, while node n-1 connects to node u. I can also say that, yeah, that is true. So you should also consider the case where your node v connects to node 0 and your node u connects to node n-1. Cool. Similarly, you will go find the shortest distance from node v to 0, which is nothing but 2, and same way u to n-1, which is nothing but 1. Again, go find it is x plus w plus y, which is 5. Oh, it is same, which means, bro, this edge for sure will come as the shortest, as one of the edges in the shortest path. So that you got the answer. So this is a good edge for you. For example, any other example, I will take again next example, u, v, weight is w, u, v. Find the shortest path. U to 0, distance is 4. V to n-1, distance is 2. Sum 9. Again, let's flip it. V to 0, distance is 3. Distance is 7. U to n-1, distance is 1. Weight is 3. Sum is 11. Again, not 5. So no matter if I do a u to v or v to u, any which ways, this edge will never come inside my shortest distance, and thus it is a bad edge. So you have realized that you will do a simple Dijkstras from node 0 so as to find the shortest distance to all the other nodes. Then you will do the Dijkstras from node n-1 to find the shortest distance to all the other nodes, right? And then you will simply apply the same strategy going on to all the edges and see if that edge is a good edge or not. Let's see the code. It's as simple as that. Again, as we are doing Dijkstras, again, this Dijkstras code is exactly the same code which we have been seeing every time, right? The only change is that I have done Dijkstras from source. I've just used, I know that I can use this as a function. Because I am applying Dijkstras from 2 points, 0 and n-1. So let's keep it as a function. in which I will have a source. So if you remembered, I will simply go and firstly build my graph, which is a vector of vector adjacency list. I'll go on to all the edges, u to v, again simple adjacency list of weighted graph, u and having a v comma w, v having a u comma w. Now you realized I want to find the shortest distance from node 0 and from node n minus 1, from both the points I want. Remember, you want it from both the points, from node 0, okay, from node 0 also and from node n minus 1 also, to all the other points. So I got two vectors. S, this will say shortest distance from source to all the other nodes, source to all the other nodes. D, this says shortest distance from destination to all the other nodes, D, this. Then I will simply apply Dijkstras from node 0. I will apply my Dijkstras from node n minus 1. Aryan, what is this true and false? It is just to say that I am actually applying my Dijkstras from a source or not. Why is that useful? Because I will, in accordance to if it is source or not, I will fill the corresponding either the source vector or the destination vector. That is the only use case of my source, and rest Dijkstras is exactly same. Again, a min heap where I have taken a pair says a distance and a source, and then simply applying Dijkstras. As simple as that. Now coming on back, we have achieved the shortest distance. Again, this SDis is from 0 to all other nodes. It is from destination, which is n minus 1, to all other nodes. All the nodes. This is a distance. I'll simply have the maqsad, the main aim, which is the shortest distance, which is the shortest distance from 0 to n minus 1. This is my main aim I have to achieve. Remember, I have to compare with this specific shortest distance, which is 5. So I have got this as the shortest distance, which is the main aim for me. Then I go on to all the edges. I check, okay, node u, node v, and the weight. I check that s distance of u, which means 0 to u plus w, v to n minus 1. If that is equal to my shortest distance, mark this as a good edge. Or v to 0, w, u to n minus 1. If that is, again mark as a true, good edge. Rn y ll, because if you know, I have initialized with the int max. So int max plus some value plus int max will be a very high value, which is more than int max. So if you will take it as an int only, it will actually overflow. So it's the reason I have taken a long rather than int max. Cool. And that's how you can simply solve it. Now complexity of simple Dijkstras, v plus e log e. Make sure it is the actual complexity of Dijkstras. And space, nothing but because of distance array, having priority queue and stuff, it is v plus e. That is how you can simply solve it. Cool. If you liked it, again, please join the Discord channel for any discussions, problem solving, dev, contest, CP, anything. Go and join it. Link down below. And if you liked it, please smash like, baby. Bye bye. Take care. And hope to see you soon in the next problem, which is problem number 3. Bye bye.